Every single day, you interact with the world around you. You touch stuff, you drink stuff, you kick stuff, you breathe stuff. You literally are stuff. But have you ever taken a minute and thought, what is stuff? Believe it or not, all of science is actually an answer to this question. If you ever hear a science teacher talk about matter, what they're really talking about is stuff. Now, of course, if you Google matter, you will find a longer definition. But for any intents and purposes, all matter is just the stuff that makes up the universe. During your lifetime, you're primarily going to interact with matter in one of three states. You're going to encounter things that are solid, things that are liquid, and things that are gas.
But what about plasma?
Well, yes, there is a fourth state of matter called plasma. But it's a little weird and it's not as relevant to day-to-day life, so I'm not going to cover it in this video. So for now, we're just going to handle the question, what are solids, liquids, and gases? Well, I'm George, I'm here in sunny Santa Monica, and I'm about to tell you.
George told me!
Substances that are in solid state have definite shape and volume, though they can vary drastically. Some are hard and others are soft. Some are unyielding, while others break with a little force. Liquids are a little different. They don't have a shape of their own, and instead change the shape to match whatever container they're in. However, they do have a definite measurable volume, which means that even if you pour them into a container of a different shape, they'll still take up the same amount of space. You also can't grab onto liquids or hold them in the same way that you can hold solids because they don't hold together very well.
No. But George, why are some things solid, some things liquid, and other things gas?
That's a great question, and to answer it, I have to tell you about particle theory. You've probably heard that at the smallest level, everything in the universe is made out of atoms and molecules. Collectively, we call these things particles, and they make up everything around us. In order to understand why things are the way they are, we need to understand what's happening at the particle level. Everything from a glass of water to a breath of fresh air to a block of wood is made up of particles. And these particles exhibit something called cohesive forces, which are forces of attraction between one another that pull the particles together. Particles with the strongest cohesive forces pull together into solids. It can take a lot of force to break these bonds apart. But if particles have weaker cohesive forces, they don't pull together so tightly. These are liquids, and while you can still see them, they can't form the shape that solids can. Lastly, we have gases. These cohesive forces are so weak that they barely hold together at all. Since particles are so small, they mostly don't even clump together enough for us to see them. This is why we, who are made up of solids and liquids, can push right through them.
But George, water can be a solid, liquid, or a gas. Is it special?
That's a good point. We all know that liquid water can also exist as ice or vapor. But no, water isn't special. Every substance can technically exist as a solid, liquid, and a gas. When we think about substances, we really tend to think about them in the state of matter that they're at around room temperature because that's what we're most commonly used to experiencing them as. However, just like water, by adding or removing heat, we can change the state of matter of anything. Even this block of metal, for instance, with enough heat, could be melted into a liquid. But what is heat exactly? If we return to our particle theory model, we know that particles naturally hold together with cohesive forces. Adding heat, though, shakes things up, literally. Heat is, quite simply, the motion of particles. The more heat you add, the more particles move. The more they move, the more likely they are to pull apart. It's a universal law that all matter has some form of cohesive forces. The differences lie in the strengths of those cohesive forces. With no heat, all substances will hold together and be solid. However, adding heat tests the strength of these forces. Substances with weak cohesive forces will break apart with just the smallest amount of heat, while substances with strong cohesive forces can take a substantial amount more. Now you know why matter exists in different states, and if anyone asks you where you learned, you can just say, George told me.